All right, once you get that recording started, let's start out with Andrea.
Hi, this is Andrea Labowie from Toyota. It's nice to be here, everyone.
Thanks. Ben Butterworth.
Hi, everyone. My name is Ben Butterworth. I'm from Acadia Center. For those not familiar, Acadia Center is a nonprofit advocacy organization. And my interest in hydrogen really started, I was involved in the DPU 2080 process, Future of Gas proceeding in Massachusetts, which got into hydrogen and alternative fuels and appropriate uses and all that. So that's sort of my background that I'm bringing here.
Perfect. Enrique.
Hi, everyone. Enrique Bosch, Head of Innovation in Avangrid. Yeah, I just introduced in my previous one, the previous meeting. Just joined the Connecticut Task Force. I think one of my colleagues here, Frank Reynolds, is also a co-chair. I'm not sure if he's attending this meeting, but I will follow up with him later. Avangrid is the utility here in the New England area, and we also are the third largest renewable energy operator in the US. So happy to be here and contribute to this meeting. Thank you.
Thanks, Enrique. Next, we'll jump to Elias.
Hello, everyone. My name is Eliasid Animas. I am also a consultant with Strategen, and I will be supporting this group.
Thanks. And then Aaron.
Hi, folks. Erin Childs, Director of Strategen Consulting. So excited to be here today.
Thanks, Aaron. Evan. Maybe we'll come back to Evan. I see Joel Reinbold.
Yeah, Joel Reinbold's here. I'm Director of Energy with the Connecticut Center of Advanced Technology.
Thanks, Joel. I'll also mention that Joel is a co-chair of this working group, and so has been doing a lot of work helping us get some of our analysis together and guiding the process in a big way. Next, I see Lydia.
Hi, everybody. This is going to sound a little bit repetitive for the folks that were in the other group. So I'm Lydia, research analyst with DEEP. I have been supporting all the efforts of the policy efforts regarding hydrogen, and I am very, very excited with the task force work.
Awesome, so are we. Next up, Sam.
Hi, everyone. I'm Sam Danowski, she, her. I'm the State Director of Sierra Club's Connecticut chapter. And here in Connecticut, we're focused on steps we can take to meet our greenhouse gas reduction targets, particularly in the biggest emitters, electricity generation, buildings, and transportation.
Thanks, Sam. Sarah?
Hello, Sarah Harari. I'm the Associate Director of Innovation and Senior Advisor to the President at the Connecticut Green Bank, and I co-chair the Hydrogen Task Force with our CEO, Brian Garcia, and the Green Bank point person that's going to be sitting in on the Uses Working Group trial.
Thanks, Sarah. Shannon?
Hi, everyone. I'm Shannon Lawn. I'm an attorney and the State Director for Connecticut for Conservation Law Foundation. And similar to what Sam said, our organizational priority is really aligning the state's energy policies with our climate goals.
Excellent. I'll circle back to Evan real quick and see if he's around to give an intro before we jump into the rest of the meeting. All right, well, moving forward, I'll go ahead and share my screen for everyone. Welcome to the inaugural Hydrogen Uses Working Group for Connecticut. Quick look at the agenda. First off, we just finished introductions, and now we'll be getting into a quick review of the working group charter and schedule for this working group. And the project as a whole. The charter should have been sent out yesterday, so hopefully you've had a chance to look at it. But if not, we'll walk through it today. This working group charter was approved at the last task force meeting, and we'll kind of set the stage for the work this working group will be involved in. So let's start with the primary elements of this charter, which are the proposed deliverables, i.e. the outcomes of this working group that will be put into the final report that's presented to the Connecticut legislature at the end of this work in January. So first, quick introduction to the different co-chairs in this working group. Joel just introduced himself. We also have Untitled Chapter and Frank Reynolds from Eversource and Avangrid respectively, who unfortunately were not able to join today, but will definitely be closely involved in the process moving forward. So a quick look at the deliverables this working group is responsible for. First, developing a structured framework to identify the end uses for hydrogen in Connecticut that should be prioritized as Connecticut develops its low carbon economy. We'll be going into detail on this framework today. It'll actually be the focus of the working group, and so you'll get we'll get more we'll get deeper into that in a little bit. Second, looking at the potential demand for hydrogen from these priority end uses developed across different scenarios. So there's some a range and some sensitivity analysis built into how much hydrogen Connecticut could potentially consume or need in the future as part of its decarbonization efforts. This will include developing something we're calling a scenario-based demand curve. So basically looking at the price points at which hydrogen would become competitive for different end uses, and then the expected demand at those price points. So looking at both when hydrogen is cost competitive, or what conditions would need to be true for hydrogen to become competitive, and as it becomes competitive, how much demand that would equate to on a statewide level. And then as appropriate, there might be opportunities to coordinate with DEEP's efforts to develop concepts for concrete projects for clean hydrogen use within the context of the regional clean hydrogen hub that's being developed in New England. So I'll pause there and see if there are any questions about these deliverables from people who are maybe seeing them for the first time or have had more time to reflect on them since they were sent out and developed earlier. All right, well, not seeing any questions. I'm going to propose that we move onto the rest of the presentation then, and really focus in on this first deliverable, which is the structured framework to prioritize hydrogen end uses, because this is a very important component of this working group's work. Hydrogen can do a lot of things, and a key outcome of this work is going to be determining what end uses are the most important for hydrogen to be developed for. And I expect there will be some vibrant discussion on these topics as we get deeper into this framework. And so I want to make sure that we leave enough time in this meeting to get into that discussion. So first, a quick overview of the kind of state of the conditions in Connecticut for developing clean hydrogen. There are a number of different off-takers that large potential users of hydrogen in the industrial sector that are being proposed as major off-takers in hydrogen hubs in other parts of the world, things like ammonia, steel mills, cement manufacturing. But as you can see from this slide here, which shows the locations of major off-takers in Connecticut specifically, a number of those off-takers are not present in Connecticut. Connecticut doesn't manufacture steel or ammonia. And so there's limited opportunities for those industries to be a part of Connecticut's hydrogen ecosystem. There are a number of other potential off-takers, things like power plants, potentially some smaller manufacturers who are not visible as icons in this slide, but are visible through the heat map that you see there. So as we move forward, it'll be important to look at some of the other end uses for hydrogen in areas like transportation and other types of industrial applications. So I just wanted to put this image in front of everyone just to level set on kind of what exists in Connecticut, what doesn't, and what that means for how we move forward. So digging into the question of potential criteria upon which to evaluate these end uses, this will be the basis for the framework that we're developing. So you can see on the left here a handful of criteria that we have put together as ways to evaluate hydrogen, dimensions upon which to evaluate whether an end use, particular end use, is a good application of hydrogen or not. Cost effectiveness compared to alternatives is one of the primary ones, and that's why it's first. If there are other ways to decarbonize a particular end use, then it would not really make sense to look at hydrogen in great detail for that particular end use if there are better opportunities. Also, greenhouse gas reduction potential is an important consideration, since the key reason for using hydrogen is for decarbonization. Technological maturity and commercial readiness are also a big consideration. One reason why off-taker analysis is so important for the development of hydrogen hubs is because you need a sizable amount of hydrogen demand to justify the development of production zones, of infrastructure to deliver that hydrogen. And so it's really important to build a market as quickly as possible, so that you can, or it's beneficial to build a market quickly so that you can scale that infrastructure more quickly as well. On the subject of infrastructure, in addition to the cost of actually producing hydrogen or the cost of transitioning a particular end use to hydrogen, there's ancillary infrastructure that needs to be developed for a number of uses. And that's something that we'll need to consider as well. Finally, question is environmental justice, workforce development, and the resilience benefits of hydrogen are all important criteria that we want to stay focused on, and that'll discuss in more detail later in the presentation. But first, I'll draw your attention to the list on the right, which lists a more comprehensive, but still not totally comprehensive, list of potential applications for hydrogen. Things like power generation, heavy-duty vehicles, industrial heat, maritime applications using hydrogen in ships, more limited applications such as warehouse forklifts or critical facilities that still may be a very valuable use of this fuel for other reasons. And the idea of this evaluation criteria, or this framework, is to assess each of these end uses on each of these dimensions listed on the left, and in doing so, determine or provide some guidance on which of these end uses make the most sense to develop. Now, these end uses, we can approach this ranking on these criteria in a couple of different ways. Here we propose doing a relatively simple approach, ranking each one from 1 to 3, 3 being the highest rank that or highest score that a particular end use could receive on a particular criteria, and 1 being the lowest, just to provide a more straightforward way of assessing whether or not an end use makes sense in a particular dimension. So I wanted to also get into each end use in turn, and provides more context on what the end use refers to, or what that criteria refers to, and how it would be evaluated, or how we're proposing to evaluate it as part of this framework. So the first one, as I mentioned, cost effectiveness compared to alternatives. This refers to the life cycle cost of a hydrogen-based technology compared to the most likely alternative decarbonization for that end use. So the potential alternative really depends a bit on the end use. You can see on the right a couple of potential alternatives for specific end uses. Some end uses might have more than one alternative, and so there could be some discussion around which is the best alternative to evaluate against. But largely, the approach would be on this 1, 2, 3 framing to have 1 be a situation in which the alternative is there is a better or cheaper alternative for a particular end use. 3 is where there's no alternative, or the alternative is not feasible for one reason or another. And then finally, 2 is an area where there's uncertainty or ongoing competition around which alternative will emerge as the best option. This could be assessed via literature review. A number of studies have been done on the competitiveness of hydrogen versus other solutions in each of the end uses identified. And so that would be a fruitful starting place to start to understand and rank end uses in this criteria. And given its importance, as I noted before, this criteria would be a bit unique in how we treat it. We're proposing to use this as a gating criteria. So basically, any end use that does not score above a 1 here would be excluded from additional analysis. That makes sense from our view, because if an end use is, if there's a cheaper way or better way to decarbonize a particular end use, then it doesn't make sense to look at how much greenhouse gas emission reductions you could get by transitioning that end use to hydrogen, for example, because there's a better way to achieve that outcome. Moving into greenhouse gas reduction potential, this is looking at the magnitude of the opportunity to reduce in-state greenhouse gas emissions by using green hydrogen. And this one can be looked at and evaluated as a function of each sector's contribution to Connecticut's overall emissions. So as an example here at the bottom, you could list all of the different end uses being evaluated according to their percentage, the percentage of Connecticut's overall emissions that they contribute to or are responsible for, and then divide up the list on the 1, 2, 3 ranking system based on where they fall on that list. So as an example here, let's say transport was an end use that we were looking at. That contributes about 37% of Connecticut's overall emissions. So that would be the top of the pack, and that would be a 3, because removing those emissions or decarbonizing that particular sector would be particularly impactful for Connecticut from a greenhouse gas reduction standpoint. Power sector, which comes in around 19%, that might be a 2, since it's closer to the center. And industrial emissions, while a very good application of hydrogen for other means, says it only contributes around 9% of overall emissions in Connecticut, might not score particularly highly on this criteria.
Colin, I apologize. I've been doing a really terrible job moderating. We have one raised hand from Andrea, but before we do that, there was also a question from Shannon about the definition for critical facilities. And Shannon, I just want to take that really quickly. I think this was actually flagged yesterday in the policy working group. And I think the plan is to work for the policy working group actually to be on point for some of these definitions like critical facilities, to make sure that we're aligned with how the state and state policymakers are thinking about that process. So please feel free to raise your hand or drop a note in the chat if you have any questions about how we're approaching that. And then otherwise, Andrea, the floor is all yours.
Thanks, I appreciate that. Going back one slide, you mentioned a literature review on whether the alternative is better / cheaper. And I would just like to make a note about how we define better. Because there is a lot in the literature, as you say, about trying to crunch numbers about cost and avoided GHG. But one of the ways that hydrogen complements other technologies is in differences of practicality. So for instance, you could show me several numbers and several papers that tell me that battery EVs are going to be a better light duty option for me. But I personally park on the street in Washington, D.C., and that wipes out any number you could give me about what is better versus the other. There's one is practically not available to me based on my lifestyle. So I'm not quite sure how to give that a number or a rank, but I'd like to kind of put a caveat under how you examine what the alternatives are compared to hydrogen. Does that make sense?
It does make sense. Thanks for calling that out. And yeah, there is definitely some refinement around this criteria, or detail, I guess, to add to the ranking system in this criteria, because there are a number of applications where the numbers might work out, but because of issues around logistics or other factors like the one that you identified, a particular alternative might not be feasible, or might be less advantageous compared to hydrogen.
Thank you.
Okay, we've got another question here. I think Ben raised his hand first, and then Shannon.
Yeah, I have two kind of thoughts here. So on the potential evaluation criteria slide, I noticed that safety was absent from that list, and I think the safety of these different end uses is going to vary quite considerably across the end uses. You can think about, combustion of hydrogen in a residential basement versus industrial applications. I think they're going to have different safety ramifications. So I think that should be considered as part of the evaluation criteria. And then on the GHG reduction potential, Colin, I noticed that you specifically said in-state greenhouse gas reduction potential. I think that could be potentially problematic to narrow the focus only onto the greenhouse gas impacts in Connecticut. I think when you talk about supply constrained alternative fuels, whether it be hydrogen or renewable natural gas or synthetic natural gas, you really have to think about the ramifications beyond state boundaries when you're using limited resources for a specific end use. For example, you can think about if northeastern states try to fully decarbonize residential heating using hydrogen, what are the regional and national implications for using hydrogen to reduce emissions from aviation or industry or other hard to electrify sectors that might be disproportionately concentrated in states outside of Connecticut. So those are my two kind of thoughts on those two topics.
That's a good call out, Ben. Yes, yeah, we'll go back and look at how to make sure we consider those factors in this criteria or elsewhere in the evaluation framework.
Ben, sorry, Colin, can I ask a follow-up question? Are you thinking about, if we're using it for one use, then it wouldn't be available for another use? Or can you explain a little bit more about, how we'd be thinking about this in a regional context?
Yeah, so I mean, there's different constraints on different resources. Like RNG, you're kind of constrained by the amount of waste methane or biomass available, and you have to think about these in terms of kind of national scales, right? It's the same kind of concept for hydrogen. If you're thinking about the amount of land required to have dedicated wind to run electrolyzers to produce hydrogen, right? It's like, where are we siting that wind? How much wind can we reasonably site as a country? How much electrolyzers can we place? How much hydrogen can we reasonably produce as a country? And then what are kind of the highest values applications of that hydrogen? Some of them might be in Connecticut, some of them might not be in Connecticut, they might be in Iowa, they might be in Ohio, So I think you have to look at an efficient allocation of these resources by considering all those different variables and the different concentrations of different industries in different states. This is kind of something that like a Princeton Net Zero America study, for example, would do. But if you're strictly focused on how do we reduce greenhouse gas emissions in Connecticut, you might arrive at a very different answer than if you're looking to solve this complicated equation from like a national scale, for example.
Thank you for clarifying.
Yes. Yeah. Thank you, Ben. Yeah, we'll reflect on how best to incorporate that into the framework, but it is important to mention. I see Shannon also has a hand.
Yeah, thank you. I had a process question. So can you elaborate a bit more on what you are anticipating for actually scoring these? Are you looking to get feedback from individual working group members, like assigning these scores based on these criteria, or will we be like working to come to consensus on these? Could you speak a little bit to what process you're proposing?
We definitely want to get feedback from the group on the scoring criteria for this part, on this framework. That's why, we have the working group to solicit information from informed parties like yourselves. And that would be a priority to do in the near term so that we can start understanding which are the priority applications to look at with further analysis. And so that's something that we could maybe discuss at the end of, during this working group to get consensus on that approach so that going forward, everyone's informed and on board with how we'll be developing how we'll be getting input on the development of this criteria.
Okay, unless anyone else has another question, Colin, I think that is the end of the hands I see here.
Sounds good. I'll keep moving forward then. To the next one, technological and maturity and commercial readiness. And this is an area where actually the safety consideration that Ben pointed out is paramount because although it's important to be able to deploy end uses quickly to build a market, it's also important that end uses that that hydrogen used for are ready to be deployed at a large scale, both from a commercial standpoint and from a safety standpoint. And so that's why, in this particular criteria, we're looking not just at whether a end use is commercially ready to use hydrogen or whether the technology is commercially available, but also whether the safeguards and the appropriate sort of equipment safety regulations are in place to make sure that this equipment can operate safely in whatever context is being used. And so the thought is to subdivide and rank each end use based on the timeline on which it could be deployed with those appropriate safeguards. Between now and 2030 would be the highest score because it would be the nearest term deployment. Then from 2030 to 2040 would be lower, and finally 2040 to 2050 would be the lowest as it's the furthest out. Infrastructure requirements. So this is, as I mentioned before, looking at the ancillary infrastructure that's needed to enable hydrogen use. So you can think of something like, the transportation sector. There's a cost to producing and purchasing a hydrogen fuel cell vehicle, but there's also a cost to developing hydrogen infrastructure and fueling stations to service those vehicles. And the infrastructure need can be different within each sector. So for example, for fueling station infrastructure, if you wanted to develop a network of fueling stations for light duty vehicles, that would likely need to be more extensive than for heavy duty vehicles, as trucks operate on more defined pathways for the most part, whereas light duty vehicles and passenger vehicles can conceivably go anywhere. So the thought here is to rank based on the new infrastructure that would be required, no new infrastructure if it's relatively late to deploy a particular end use in terms of infrastructure needs. That would be a 3. Isolate infrastructure needs, when it's you only need infrastructure for a relatively limited number of sites. that would be a 2. And then in a situation in which you have to develop infrastructure across the entire state, that would be the hardest to deploy and would be a 1.
Colin, quick question on this one. For the infrastructure requirements, will that also be taking into account available funding for that infrastructure, or would that be considered separately?
It's a good question. I suppose if there is a situation which a particular type of infrastructure has dedicated funding that other infrastructure might not, you could factor that into the ranking. But at the moment, we're not really considering subsidies or external funding opportunities when looking at this. So moving on to environmental justice and workforce development, these are 2 separate criteria, but they can be evaluated kind of on a similar scale, kind of on a do no harm principle, i.e. a median score implies that there's no change from the status quo. And so for environmental justice, that could be something along the lines of, a 1, the lowest score is a situation in which using hydrogen would increase local pollution compared to the alternative. A 2 keeps local pollution the same as it would have been, and a 3 reduces local pollution. Similarly, around workforce development, if it reduces the workforce need, that would be the least desirable option. If it keeps the workforce need the same, that would be a 2 or a neutral option, and a 3 would be a situation in which it increases the workforce need and so far, and in so doing contributes to economic development. And then finally, getting into the question of resilience benefits. This refers to the ability for a system to respond to inclement events like extreme weather, but also things like fuel constraints, supply chain disruptions. And the thought is that hydrogen provides a certain amount of fuel diversity, which improves resilience by reducing the reliance on a single network. For example, reducing the need for a particular end use to rely solely on the electrical grid. And there are some end uses where that resilience value is particularly important and where we could prioritize hydrogen development. So in this case, a 1 would be the resilience is not of major importance for that particular end use. A 2 would be a situation where resilience is valuable but not critical. And then 3 is where resilience is a critical need for that particular end use. And so the fuel diversity benefit of hydrogen is particularly valuable. All right. Well, thanks for kind of your reflections up to this point. I also prepared a number of questions where it would be helpful to get your input going forward as we continue to develop and refine this criteria. The first being, what aspects of this value criteria are valuable or useful, and what areas should be changed. I know we've had a couple of comments on that front already, but would definitely appreciate if we took some time now for anyone who's not spoken up but has some thoughts to weigh in on that area, or any of the other questions that you see in front of you.
I can chime in. With respect to the environmental justice criteria, I just wanted to note that on the previous slide, the characterization you had was like whether it would be increasing local pollution. And well, I think that's a good starting point. I think we also need to tie this specifically to disadvantaged environmental justice communities. And I know there have been discussions at DEEP and the Connecticut Council for Equity and Environmental Justice about how exactly we're defining environmental justice communities. And so there's probably some discussion to be had there. But I think the main focus should be on ensuring that we're not increasing burdens on communities that are already overburdened by environmental harms and energy infrastructure. Rather than just, increasing pollution anywhere, which might make citing anything unrealistic.
Thanks, Shannon. That's a really good point.
Actually, Shannon, if you wouldn't mind, I have a follow-up on that. And Colin, would you mind going back to the environmental justice slide? So I guess just, Shannon, I think one of the specific questions we've been discussing, and we really welcome feedback on this, is when we were looking at environmental justice in this context, we were thinking heavily about local pollution and the opportunity for hydrogen to displace combustion of fossil fuels that may have particularly significant local air quality impacts. And I think one of the things we're trying to pressure test here is this, when we talk about environmental justice, is local pollution the appropriate focus, or are there other components that we should be thinking about in our evaluation approach here? And so if you have any thoughts on that, we would be especially open to feedback.
Yeah, I mean, I think that displacing fossil fuel combustion with hydrogen is definitely something that should be considered. I was also thinking, as my prior comment was suggesting, about the actual siting of, for example, like hydrogen infrastructure, where that could pose a burden to local communities as well. So I think that also should be considered. And then one more note, just on the importance of appropriately defining like overburdened or disadvantaged communities. I know that we have in state statute the definition, and then there's also the distressed municipalities, which are designated by DECD, I think. But one other thing that I think CJAC is going to be talking about is the importance of race as a predictive factor of which communities are overburdened. So just wanted to add that as well, that I think it would be most equitable if that is factored into the decisions and figuring out, which areas are most overburdened currently.
Okay, that's really helpful. And I guess just one thing I'll note, maybe as a slight teaser trailer for one of our upcoming work groups, is that the infrastructure work group is planning to do a bit of a geographic assessment and sort of looking at regions of development. And I think, we've historically developed maps that do include indices like minority populations, low income populations, and if there are resources specifically on disadvantaged communities or other kind of communities of concern, it might be interesting to find ways to layer that over some of these infrastructure maps. Shannon, does that sound like maybe an approach that could be helpful to at least creating visibility about how we're planning and considering these elements?
Yeah, absolutely. And I know, I think it's still under development, and maybe the representative from DEEP can weigh in on the status of this. But I think DEEP is also in the process of updated mapping for environmental justice communities. And so it sounds like there are some various sources that could be brought together to better inform this discussion.
Okay. Really helpful. Thank you so much, both Shannon and Lydia. And Colin, I will, back away from the microphone. Thank you for letting me steal a little bit of time.
No problem. Appreciate it, Aaron. Very important questions to get right. So, maybe focusing on specific questions here. I'm curious if anyone has any additional criteria that we want to be ensure or want to make sure to consider. I know that Ben suggested potentially factoring in out-of-state greenhouse gas emission reduction potential as well as a consideration for how we're evaluating these different end uses, not solely focusing on in-state emission reductions. Are there any other criteria considerations that people feel are not present or not being represented right now that are important to make sure we include?
I just added this in the chat, but I think Ben had also suggested that we be considering safety as a separate criterion, and wanted to voice support for that. as well as for the broader considerations of GHG reductions, both within and beyond the state?
Thanks. Yeah, that's a good one to circle back to. Because I remember we started discussing that earlier on in the presentation. Is there still, appetite to have safety be its own separate criteria versus being included in another criteria such as commercial readiness? Ben and others interested in for you to weigh in there.
Yeah, I think it makes sense as its own criterion, right? Because there's a difference between, do we have a residential boiler that can blend, that can combust a 40% hydrogen blend versus, our firefighting staff trained to deal with, a nearly invisible flame in a residential setting, that type of thing, So I think, anyway, I won't get into it, but I think as a standalone criterion, it makes sense.
Would this be comparative safety, like compared to the status quo, or what are you thinking about there, Ben? I mean, I'm thinking about some of the end uses like aviation, or what are we comparing the safety rating against that you would be interested in seeing?
Yeah, it's a good question. I mean, I think the safety compared to the most competitive alternative, right? So what is that most likely alternative in aviation? What is it in residential heating? What is it in industrial process? But I'm mostly thinking about it in terms of, I guess, relative to each other as well, right? Like if you have hydrogen being combusted in an industrial facility where there's someone 24/7 dedicated staff member to like monitor the safety of that equipment, right? Versus like in someone's basement, it's a very different situation, right? There's no professionally trained staff like responsible for that equipment. So I was thinking about it, I guess, in both contexts.
Yeah, the reason I'm asking is just because we went back and forth with Stratagen about, how it was appropriate to incorporate safety because it touches so many of the other categories like greenhouse gas reductions. It has to do with health safety impacts. So yeah, certainly something we can take back and think about how to incorporate it.
And I guess just chiming in here that, the other thing we've also talked about is, I think another way to potentially think about safety is just the maturity of safety rules and regulations. So for example, as we are seeing additional use cases for lithium-ion batteries and getting a better understanding of safety considerations, we're starting to see a much more rigorous and robust set of safety protocols that are getting put in place so that folks can feel comfortable with deployment of lithium-ion batteries and know that we have the appropriate steps taken if anything were to go wrong. I think we're excited to be bringing some folks to kind of get an additional safety lens, hopefully at the next task force meeting. And maybe something we could try and tease out is sort of where is the maturity of different safety rules and regulations, because Ben, as you've pointed out, in industrial applications, hydrogen has been in use for years and years, right? And folks have a lot of policies and practices in place. There are other places that we're talking about relatively new applications for hydrogen. And so, getting a sense of how folks are thinking about that portion of, deployment needs.
It's a good point. Yeah, there's a lot of ways to think about this, off of what Aaron said. One framing is, to what extent are new regulations required? Because a lot of new regulations will be required across the spectrum of technologies we're deploying for the clean energy transition Connecticut's. To what extent are we working with new or novel applications that would require new protocol to be developed? And obviously, as new protocol are being developed, or any situation in which new protocol is being developed, there's a greater chance for accidents, and so that would score lower on the safety on a safety metric. See a question from Andrea about the score just being specific to locations. I see that being most relevant for things like environmental justice and workforce development. And that might require some, location specific analysis, but especially if we're paying attention to frontline communities or more traditionally disadvantaged communities, as Shannon pointed out. And I think there's a potential to add that level of analysis as we evaluate it on a statewide level. So for example, hydrogen being used in power plants or to replace natural gas in gas peakers. That's an application that would have very specific local impacts in terms of local pollution and relevant to the communities around those power plants. But we know where the power plants in Connecticut are. And so to provide a statewide score, we could say, okay, if we were starting to use hydrogen in these facilities, what communities would they affect based on where the power plants are currently located? And so that's one way to particularly to approach it potentially. Similarly for heavy duty vehicles, we have data on where the largest pollution impacts are for heavy duty transport in the state today. And so understanding that would give us perspective of if heavy duty vehicles were switched to run on hydrogen, what communities would be affected. And so in that way, we could approach, I think, evaluating this on a state level. Yes, Ben?
Yeah, one thing I'd add, I mean, when we're talking about cost competitiveness versus alternative technologies, like if you look at the future of gas study in Massachusetts, one thing they found is, it's not hydrogen versus electrification on the building side, right? It's a combination of hydrogen, renewable natural gas, and synthetic natural gas compared to electrification, right? So what I'm saying is that hydrogen, if you believe the blending limitations in our current distribution system, it's not a one-to-one comparison versus electrification, right? You have to think about, if we're going to fully decarbonize the gas system, what else do we need? We need RNG, we need synthetic natural gas. So it's also the cost of those fuels compared to electrification, which makes the entire matter much more complicated as the future of gas analysis is going to. But I just wanted to point that out. I mean, it's one thing if you're looking at the cost of kind of marginally reducing emissions 5% in the building sector, for example, versus if you're thinking about cost in terms of what does it cost to fully decarbonize the gas distribution system or fully decarbonize residential or commercial heating. So they're two kind of different questions when you factor in the blending limitations of hydrogen. So just something to point out.
Yeah, that's a good point. And I'll circle back to the end uses here because relevant to that comment, wanted to note that we're actually looking at evaluating like hydrogen pipeline blending and then hydrogen use for residential commercial heat as kind of like two separate end uses, where hydrogen pipeline blending might be just putting hydrogen into the current natural gas system without any infrastructure upgrades, which is not like a full decarbonization solution. And so it would potentially score very low on like greenhouse gas emission reductions, but very high on, infrastructure, new infrastructure needs, because fewer infrastructure would be needed. Whereas residential commercial heat, that could refer to supplying all of residential commercial heat by hydrogen, which could score very highly on greenhouse gas emission reductions, but very low on things like cost competitiveness or additional infrastructure needed. And so that's one way we're thinking of separating those two applications. We don't really have in this framework a approach for evaluating a kind of gas decarbonization scenario that depends on both hydrogen and other greenhouse gas or low carbon fuels like renewable natural gas. It's possible we could evaluate that as well as and have things like the additional cost of ancillary fuels to supplement the hydrogen that you're blending into the pipeline, ancillary low carbon fuels being something like a additional infrastructure requirement. And so having that system score low on that particular front. But your point is well taken, Ben, that these are very complex questions. And in some cases, if it's given the time constraints that we have in developing this analysis, we can't reproduce DPU 2080 here. And so we might end up, or the most expedient way to approach that would be to use like a neutral score, like a 2, in areas where there's a particularly significant amount of complexity. In a way, that's what the 2 is meant to represent in the cost effectiveness criteria. A situation in which there is uncertainty or ongoing competition.
Yeah, that makes sense. I mean, like in the pipeline blending example, I guess one way to think about it, and one thing the evaluation criteria might not be capturing, right, is let's say we do 7% by energy content hydrogen blending, right? That reduces emissions from the gas distribution system 7%. But is it really compatible with Connecticut's long-term vision of a net zero economy, right? Does it get us closer to that? Or does it just get a 7% reduction and that's kind of the end of it, right? Mm-hmm. So I don't see that concept really captured in any of these evaluation criteria. I guess you could like argue it's captured in the GHG impact criteria, right? But if I don't know, so it's just one thing to think about. It's like there's a difference between kind of these marginal incremental emissions reductions, which are useful in their own right, but it's like, are they compliant with the overall vision we see for decarbonizing Connecticut's entire economy?
Yeah, that's true. And right now, I feel like that would best be captured in the greenhouse gas emission reduction potential that you identified, but also like this cost comparison criteria. If it is the case that it's more cost effective to decarbonize heating in Connecticut by electrification, then this hydrogen blending option could score very low on this particular criteria, because ultimately hydrogen blending is not the most cost-effective way to decarbonize this sector. If eventually the pipes that hydrogen is being blending into will not be used because the majority of the system is moving to electric heat. But yeah, these are very sticky questions and a little challenging to capture all these nuances in a concrete set of criteria that we're trying to develop something that will provide some focus and guidance for evaluation of these end uses, but there is a lot of nuance to capture. I agree.
And I think the other thing, and Ben, I appreciate you raising these questions, because I think you're asking kind of like foundational questions of, how are we making sure that this aligns with the broader vision and strategy for decarbonization, and how are we ensuring that we're, investing in resources that will be used and useful and that will, continue to align with the direction of the state. These may be pieces that also are appropriate to pick up in some of the crossover between working groups. I know the policy working group yesterday discussed fairly explicitly the importance of alignment with existing state policy and state statute, and is I think going to be asking all the other working groups to make sure that they're identifying, to the extent that there are recommendations, how do these recommendations get incorporated into ongoing, state policy processes? So I think this is, I guess I just don't want us to feel constrained that we have to address every single one of these questions in specifically the uses working group, because these are topics that really cut across, I think, the overall objective of the task force. And so we can certainly flag these, carry them forward to the task force, carry them forward in other work groups, or kind of address them in terms of how we bring those together. So I don't know, I guess, Ben, just interested in your thoughts and reactions on, you know, what you feel like might be the most productive way, or if you have any thoughts or recommendations on that front.
Yeah, I'm not sure. I mean, they're all intertwined, right? Like, I think the discussion on appropriate end uses, right? It gets into discussions on supply and kind of discussions on overarching policy. And the discussion on end uses, it also, yeah, it gets into discussions of what is the overarching trajectory towards a net zero economy, right? I don't know, they're all interrelated, so it's hard to comment on what would be most valuable for this particular working group to do, besides kind of like highlight those potential concerns that might not necessarily be captured neatly in some sort of scoring evaluation matrix, but are nonetheless kind of like central to this entire discussion. And I don't know, I'd argue incredibly important for figuring out how to use hydrogen appropriately in Connecticut.
Yeah, absolutely. Okay. Well, let us take that feedback. I have a couple of thoughts on some steps that we can take to make sure we're bringing that more holistically into the process. And I think we can plan to follow up with this working group as well as probably the rest of the working groups on some of the thinking and approaches there to make sure that we do have integration. You know, these work groups are not intended to operate in silos. They're not intended to go out, come up with the perfect answer, and then that's, you know, written on the stone tablet that we take forward, right? This is a chance for us to get feedback and to identify those places where we need to draw pieces together and ensure that connective tissue. So we will take that feedback and see what we can do with it.
Thanks, Aaron.
Great. Well, with that, I think it's a good time to let everyone go. I know we're at time, but we've got some great feedback. We'll follow up soon with thoughts on, you know, any adjustments based on your insights, and then also next steps for moving, you know, actually scoring and uses of this criteria, and then moving forward with the analysis and getting a process for getting input on that component of the work as well.
Thanks all. Thanks all.
Thank you, everyone. We'll talk to you later.
Everybody.
Thanks. Bye.
Thanks, folks. Take care.